Hey Olivia, how's it going? So yeah, your dad gave me this worksheet. I'm gonna go over it with you really quickly, or a few of them. I'm going to assume that the ones you've answered over, oops, excuse me, the ones you've answered over here are that you know how to do. Okay? It looks like you know that in order to take the root, any roots of a negative number, then it has to be odd. Okay, this number has to be an odd number to take the roots of negative numbers. If it is an even number, so say you had if you wanted the square root, excuse me, if you wanted the square root of say -4, well, it doesn't look like you guys are doing that. That would involve imaginary numbers. You'll get into I believe, at some point this year if you haven't already. But since all the roots look like they are odd numbers, that allows you to find like the fifth root of say -748, which you did, and those all look correct. I see that you didn't put an answer to number 6, but I see this right here. So let's see if that's the answer really quickly. Or excuse me, number 5. So number 5, if you were confused about it, you might be overthinking it a little bit. It's really just plug and play. They give you this equation, and they say that the kinetic energy E is in joules in this equation, and they also say M, which is the mass, is in kilograms. So in order for this equation to work, to solve for any of these variables, if they give you the energy or the mass or the velocity, they have to be in joules, kilograms, and meters per second, okay, respectively. So here they just want you to find the velocity, so they want you to find v. So really this is just a plug and play, okay? They gave us our energy, okay, in joules. They gave that to us, okay? So we just set it up just like the equation. I'm sure you're used to solving equations by now. So we're just going to set up the equation. We're going to put in everything we know and solve for what we don't know. Do we know the mass in kilograms, which is what we must have to solve it? Yes, we do. It's right here. So 0.148 kilograms, okay? Now, what we don't know is the velocity squared. We don't know the velocity, but in the equation it's squared. In order to solve for energy, the velocity must be squared, okay? So really this is just balancing the equation, isolating the variable, that's it. Isolating the variable while keeping the equation balanced. So let's just start eliminating factors here. So we're multiplying by 1/2. So in order to undo multiplying by 1/2, we're going to multiply by 2. Okay? We're multiplying by 1/2. We could divide by 1/2, which is the same as multiplying by 2. But so we just multiply both sides by 2. We multiply both sides by 2. If we multiply 1/2 by 2, we get 1. Okay, well, 1 times anything doesn't change that, whatever it is. So now 90.65 times 2, 181.3. Okay, so now our v squared, or our v, which is being squared, which is what we're trying to isolate for, is being multiplied by 1.148. So in order to undo that and get this v by itself, we have to divide by 0.148. Okay, that point should have been down there. So after we do that, we know those divide to 1. 1 times anything is just itself. So we get v squared. We also know what we do to one side, we must do to the other side. Okay, So 181.3 divided by 0.148. It's like 1,225. See, I already did a little work there. So now, let's just say we have 5 squared. Okay? 5 squared is 5 times 5. It equals 25. Okay? If all we were given was 25, and we wanted to know what was squared to get to 25, well, that's called the root. We know that's 5. Okay, so it's the same way over here. Okay? This is, we take both of those, they both equal 5. We did the same thing to both sides. So we can just do the same thing to both sides here. Well, we know the square root of something squared is just that thing. So now what's the square root of 1225 is 35. Now, it's automatically in meters per second because that is what the equation, as long as the energy is in joules and the mass is in kilograms, then will automatically give you the velocity in meters per second when you solve for it. So that's the first one. I wasn't sure. I saw this. Okay, so I'm going to pause it because I got a class coming, and I'll be right back. Okay, so I'm back. All right, so that was number 5. Again, I see that you got 35 meters per second. So, but I didn't see any work, so maybe, I don't know, maybe you got that from somewhere else. But anyway, basically, number five is just to plug and play. They pretty much give you everything to set up the equation with the exception of V. So then you just have to solve for V by isolating the variable. Maybe the sticking point was when you got to, V squared equals 1,225. But 1,225 just happens to be a perfect square. So when we take the square root of it, it's 35. And you can check that by doing 35 squared, and you will get that. So again, it's just equations. You can do anything you want to an equation as long as you do it to both sides. I won't promise that everything you do will be productive, but as long as you do it to both sides, you haven't done anything wrong. You may or may not have made progress, but you haven't done anything wrong. But when you wind up with something squared, like V squared right here, equals something else, well, you can just take the square root of something squared, and that will just give you that something. Okay? But you do it to both sides, so 35 equals V. We know 35 is in meters per second because it's inherent in this equation. It will not work. If the velocity is not in meters per second, or the energy is not in joules, or the mass is not in kilograms, then that equation will not work. So, okay, so let's go on to some other ones here. Okay, so again, I'm going to assume that this is your work. You have done everything correctly to this point, okay? This is correct, all right? You knew that the 27 to the 1/3, or the third root, the cubed root of 27 is 3. You got that right. And looks like you did, looks like you knew that 24 to the, we'll say 3/3, which is the same thing as 24 to the first power. If you were to multiply that times 24 to the 1/3, you would get 24 4/3. So you were able to take out that 24. But in order to simplify further, okay, you've essentially got, 24 to the first power, to this first power, is just 24. So what you have is 24 times 24 to the 1/3 over 3, okay? Well, we've got some canceling out we can do here, right? Because we're dividing by 3, so we can divide this 24 right here by the 3. 24 divided by 3 is 8, so we'll put equals. I'm going to have to erase this, so you might have to rewind. But anyway, so 24 divided by 3 equals 8. Now, 24 to the 3rd power, okay? You know, if anything is to a fraction, or especially a fraction like 1/3 or 1/2, you know anything to the 1/2 is just the square root. Well, anything to the 1/3 just means the 3rd root or the cube root, okay? So what we really have is we did our little division here with our 3 goes into 24 8 times. So we have 8 times the cube root, that's cube root, or 3rd root of 24, okay? But we're not quite done yet, okay? So again, when you're trying to simplify things underneath this radicand, if it was a square root, we'd be looking for perfect squares. But since we're taking the cube root, we're looking for perfect cubes that are factors of this 24, okay? Some of this I can tell that you know, possibly you know, because I see some work here. And again, if this work here that I see comes from somewhere else, and you're actually not as familiar with this material as this work would indicate, just shoot me an email or something, or have your dad text me or whatever, and I can go over some of this in more depth. I don't have a problem doing that. Okay, so what we have is 8 and then cube root, and I'm going to go ahead. I know that 8 times 3 is 24, okay? Now, we're looking at this 8. That is actually a perfect cube, because 2 to the 3rd is 8. 2 times 2 is 4, times 2 is 8. So, that means we can take it out from underneath our radicand, or radical sign. But when we do that, we have to take the 3rd root of it. So we have 8, or the cubed root of 8 is 2. We take that right out here and we change it to 2. So 8 times 2, and then we just have times the cube root of 3 still left over. 8 times 2, 16. Cube roots of 3. Okay, so that's your final answer. Okay, so really, you were on the right track here with this. You just needed to go ahead and divide, get your 8, and then just realize that this can be simplified more, and in my mind it's easier if you go ahead and just write it. 24 to the 1/3 is just the cube root of 24. Okay, so yeah, so that looks to be your final answer, unless I've made some kind of mistake. If I have, I think you can still see the mechanics of it. Some of this, like I said, it looks like you know what to do, or you know the general procedure, because indeed I checked this one, and this is correct. This is absolutely correct, and there's no more simplification to be done. So so that's the answer for number 6. 16 cube roots of 3. That is actually the answer for number 7. This is a good answer for number 8, and I believe that's a good answer for number 9. Like I said, if I asked your dad if the stuff that you had written were the ones that you knew, he said he thought so I'm not covering it if it looks like you know it. Looks like you know the properties of things with like bases, okay? Exponents with like bases, you just subtract if it's in a quotient form like this, or if it's in a fraction form, you just subtract the bottom from the top. So it looks like you know what I mean by that because you subtracted 1.35 from 2.7 and you got 1.35. And that is exactly right. You got a positive 1.35, which means it stays above the fraction bar. And since it stays above the fraction bar, this actually divided out. It canceled out this down here, so you have 1.35. And the 4 just stays the same. So that's correct. I don't know. Yeah, if you don't know how to get these, because I don't really see any work here, maybe you just try some things on your calculator, you know, to see what perfect squares were inside of 80 that you could get out from underneath the radical sign right here, you know, and that's how you came up with that. And you did the same thing for 245. But it looks like if you did this work, it looks like you essentially know what you're doing. You might have hit a roadblock here, but just remember, you can just keep on doing things. So just go ahead and divide this 24 by the 3. It's going to give you the 8. Then just, you know, I like to convert anything to the 1/3 or 1/2 power or anything. That just means it's this root. Okay, so it's the cube root of 24. We know 8 times 3 is 24, so we know 8 is perfect cube. We take that out, and so forth and so on. You can rewind. To recap everything, I don't want to bore you to death. Now, okay, so I'm looking at number 10. That looks good to me, and you rewrote it in the proper form. And I don't see why our domain would not be all real numbers. It seems like any real number will work. So I think you are correct on number 10. Number 11, you have, okay, it's just gx times gx. So negative, so a negative times a negative is a positive. When you're multiplying like bases, you just add. So that's exactly what you did. When you have like bases, you just add the exponents. That's what you did. A negative times a negative is a positive, x to the 6. Looks like all real numbers will work for that. Yeah, so I don't know. That looks good to me too. Now x to, let's see, number 12, g of f of x. I see you have it set up. Okay. So negative. So that's right. So you put this f of x inside g of x, which means you substituted this whole thing for the x, which is exactly what you should have done. Now, I see written out to the side, or saw the formula for cubing, or the thing you memorized. So let's check that out. So whatever our answer is, it's going to be negative, okay? Because it's outside of the parentheses, okay? So let's see here. Hold on just a second. Okay, so yeah, I saw where you had memorized, you know, the a, whatever it is, a cubed plus 2ab. I can't remember exactly. I try not to memorize things like that if I can help it. What I do know is if we want to do that problem, we can say x squared minus 4. And for now, I'm going to not worry about this negative sign because it's just negative whatever we get, okay? It's not, since the negative is outside of the parentheses and not inside, then we're not multiplying negative times negative. It's just we evaluate this, what's inside the parentheses, to the third power, and whatever we get is negative. So, so we get x squared minus 4. What I'm going to do is do x squared minus 4. I'm going to go ahead and evaluate this. So I'm going to do the old FOIL thing, because I don't memorize things very well, or unless I absolutely have to. So first, outside, inside, those cancel, and last, so we have x to the 4th plus 16. Okay, now it was cubed and not squared, so let's do, okay, first, outside, inside, last. So we can combine some like terms here. So it looks like we have x to the 6th. If it's minus 4x squared plus 16, that's going to put us around about 12x squared minus 64. Okay, I believe that is oh, excuse me, it's to the 6th. I believe that's what you're looking for there. Yeah, the x to the 4th is a little suspect here because we know, okay, if this is actually, and also, forgot one last thing, we know that it's negative. Okay, this negative distributes through, so negative x to the 6th minus 12x squared plus 64, actually. I believe, unless I've made some sort of error, I believe that is what you're going to come up with. This x to the 4th was a little suspect because I know that at a minimum you're doing, you know, x squared minus 4. You can even read that, which I'm sure that you can't, so let me do it again. Well, we'll just pretend that you know that all three of these would be inside this. So you're going to have x squared being multiplied 3 times. So eventually you're going to come up with an x to the 6th. So I would check this one. You can use your formula. The thing about that formula is, though, when it's a little more complicated, it gets a little tougher sometimes. The formula is sometimes not as easy as just saying, okay, I'm going to start out by squaring it, and then I'm just going to multiply it times itself one more time, and that'll mean it's been cubed. So, and it's just the same thing. So, you know, I just did x squared minus 4, x squared minus 4, excuse me. X squared minus 4 and x squared minus 4. You can't read, but that's x squared minus 4. Okay, that is, you know, all of this is negative. Okay, the whole thing. Okay, so we can just do, I just FOILed these two and came up with an answer, came up with this, okay? And then I just multiplied it times this one more time, which allowed me, since I've got two terms in each one, I can just use my FOIL again, okay? And then I just had to remember that whatever I come up with is negative, and I just distribute that negative sign to each term, okay? So unless I'm horribly mistaken, I'm a little rusty on this stuff too, to be honest with you, which is kind of why I wanted to do this, because it's good practice for me as well. If you don't do this, you kind of forget how to do a lot of this stuff. So that looks like number 12. As far as the domain, I don't see why it would be restricted unless I'm missing something. I think it's going to be all real numbers as well on that. Yeah, I don't see any restrictions on that one. So that brings us to 13. A rental car costs 35 bucks for a day. It's 5 cents per mile. The car averages 30 miles per gallon, so the total mileage is given by the equation. Find the cost after using 8 gallons of gas. And find the total. Okay, so this is just a nested function, which you have already seen how to do. So we have this equation, and we have this equation. So find the total after using 8 gallons of gas. Okay. There's a more common sense approach to doing this, but we'll go ahead and do the nested function, or yeah, because that's the way it's written. So we essentially...
Autumn McKenzie, please come to the front office. Autumn, to the front office.
Okay, let's see, Autumn McKenzie. Got distracted there. Okay, so if C of M equals 35 plus 0.05 M, where M represents the mileage, okay? So M is 35 miles, or 32, averages 32 miles per gallon, okay? Per mile. So C of M of G is going to be 35 plus point
Stacia Williams, please come to the front office. And Stacia Williams, front office.
Now, find the total cost after using 8 gallons of gas. All right. So M represents the mileage, okay? If we used 8 gallons of gas, let's just do this a common sense way. So if we used 8 gallons of gas and we get 32 miles per gallon, so 32 miles per gallon, okay? That's 32 to 1. Okay. Okay, we're back. All right, so I actually took another look at this problem, so let's start over. So they tell us, they give us c of m, okay, as a function. So it's 35, and sorry, that we're having to go back over this. 0.5 m, okay? And then they give us m of g equals 32g, okay? So they want to know c of m of g, all right? So all we do is take m of g and substitute it in for this m. That's how you do nested functions. So m right here is determined by this right here, because m is a function of g, okay? So we can find out, all we have to do is just rewrite our initial equation, and then instead of m, we put in m of g, because m is actually determined by g. So m of g, we don't put in m of g, we actually put in the number 32g, okay? So now all we have to do, they actually give us g, 8 gallons. So all we have to do is plug in 8 for g right here and solve the equation. I'm running, oh, let's just do that. Give us a little bit more room. So all we have to do, c of m of g is 35 plus 0.05, 32 times 8. Okay, so (32 times 8) gives us 256 right here. So if we take 0.05 times 256, that gives us 12.8, and we just add 35, so we're at $47.8 is our total cost, C of M of G. So whenever they have this and they want you to nest these functions in here, okay, all you do is just take this function, this m of g, and plug it right in where m is, okay? And that's all we did, because m of g is 32g, so we just plugged in, you can see right here, 32g, because this 32g will give you the mileage, okay? It will give you m. As soon as you know g, you know m. M is a function of g, so it gives you this m right here, okay? Which is your input, or your independent variable on your initial equation, which calculates the total cost, which that's what they're worried about. So it looks like $47.80. Okay, $47.80 on that one. Sorry that took so long. That one was. It's just that's an odd problem. You usually don't think of things like that. Make sure we haven't skipped anything. Okay, inverse functions. So I'm going to erase this. Okay, so an inverse function, just what you need to know is whatever, it just undoes what the function does. Okay? It just whatever is being, a bunch of stuff, what a function does is we have this variable, we choose what the variable is, or we input something, but the function just does stuff to it. So in this case, x is our variable, so it gets multiplied by 3 and then 4 subtracted from it. Okay? So the inverse of the function just does the exact opposite of that in the opposite order. Okay? So if we go back to order of operations, you think about it, okay, what do? You multiply first, and then you add and subtract second. You do parentheses, exponents, multiplication, division, addition, subtraction, in that order, right? So here, you multiplied first, and you subtracted, so you multiplied 3 times x, then you subtracted 4, okay? So the inverse of a function is going to undo those things, but it's going to undo them in the reverse order of your order of operations. So instead of PEMDAS, it's going to go this way, okay? So you can see right here, we're adding 4 to x and then dividing by 3. So we did the opposite of this one. We added 4 to it and we divided by 3. So that right there is enough to know that g of x here is an inverse function of f of x, okay? But the way you find an inverse function is really simple. You replace f of x with y, and then you solve for x, I believe is how you do that. Hold on, let me pause 1 second. Okay, yeah. I knew you did something like this. Anyway, replace f of x with y, but then, okay, swap your x and your y. So put x equals 3y minus 4, okay? Then you solve for y, all right? So if we're going to solve for y, we're going to isolate the variable y. We're going to add 4 to both sides, right? So we add 4 to this side, plus 4. We add 4 to this side, plus 4. So we have x plus 4. And then this obviously sums to 0, so you have 3y, okay? Now, to get our y by itself, we're going to need to divide both sides by 3. So that divides to 1. So we have 1y, which is just y. We have x plus 4 over 3. So yeah, it's been a while since I've done some of this stuff. So just change your f of x, whatever your function is, okay? Like here we have f of x, g of x, whatever. Just change that to y. Rewrite it. So y equals, we'll just work on the next one. I'm going to erase this one. And we'll see. Okay. So, okay, is this 5th root of x over 2, is that the inverse? Okay, let's try it again. So we're going to replace this f of x with y equals 2x to the 5th. Then we're going to switch our x and y. Okay, so we're going to say x equals 2y to the 5th. Then we're going to solve for y. Okay, so first thing, we're going to divide by 2. All right, divide both sides by 2. Okay? That divides to 1, so you've got x over 2 equals y to the 5th. Okay? Now, if we want to get y by itself, we know it's y to the 5th, we will take the 5th root. Okay? So, because anything, just like if we had y squared, if we took the square root of it, that would just equal y. Okay? So, we'll do that. We'll take the 5th root of y, we'll take the 5th root of this side too. Okay? So the 5th root of y is just y. So the 5th root of x over 2 equals y. This should be the inverse, x over 2. Okay? So that's your process. Take your initial function, the one you want to find the inverse of, replace f of x or g of x or whatever of x, replace that with y, then just swap x and y, and then solve for y, and you can see you wind up with y equals something. Well, once you isolate y and solve for it, that expression that you solve for is the inverse of your function. Okay? And if you'll notice, it actually undoes every operation that is done to x in reverse PEMDAS order. But you really don't need to know that. All you need to know is f of x equals y. Write that, swap the x and the y, then solve for y. And that'll give you your inverse. So yes, those indeed are inverse. Let's see. I guess it's the same instructions. I kind of chop this up into pieces. Verify that they're inverse. Okay. Oops. Okay, so same thing. 3x to the 8th power. So I'm going to do y equals 3x to the 8th power. They've restricted your domain here to 0 or negative numbers. Since this is an even exponent, that doesn't really matter because negative numbers are always going to end up positive. So I don't quite know why they did that, but they did. So that one I'm not too clear on why they restricted that domain. Maybe, who knows. But anyway, I'm not sure of the, let's see. I think we're supposed to find the inverse of those. Let me look at your thing here. Okay, just find the inverse of the function. Okay, so easy money. We got this. Now let's swap them. X equals 3y to the 8th. Okay, let's divide both sides by 3. This 3 and this 3, they divide to 1. So that's just going to leave us with, because 1 times y to the 8th is just y to the 8th. This is still x over 3. Okay, we know if we want to get y without this exponent, we can just take the 8th root of y to the 8th. Okay, so we take the 8th root, but we do it of both sides because we have to. So what we wind up with is the 8th root of x over 3 is the inverse function. Okay? We'll go to 17. We'll just go ahead and replace g of x with y. Looks like 3 halves x to the 3rd plus 4. Okay? We swap x and y, so x equals 3 halves y to the 3rd plus 4. All right? If we're going to isolate this y, of course, let's go ahead and subtract 4 from both sides. So minus 4, so we have x minus 4 equals, this cancels out, 3 halves y. Okay, so Now, we need to divide by 3/2, obviously. So if we divide by 3/2, this is going to cancel to 1. Cancel to 1, so we're down to our y. So when we divide by 3/2, how do you divide by a fraction? You flip and multiply, right? So we flip this over, and then we multiply it times this whole thing, okay? So what we have is 2/3 times x minus 4, okay? Well, we know we can just multiply this across, you multiply the numerator times anything like that, so what you end up with is 2x minus 8 all over 3 equals y. And that should be the inverse of your function. So yeah, that's how you find the inverse of functions. So let's see. I've got some here, looks like it's not on the test, so I'll skip those. We'll go down to 22. Okay, solve these equations. Same thing, okay? Just like if, if you had 2 squared equals 4, all right? Well, the square root of 4 is 2, okay? So if the square root of 4 is 2, the square root of 2 squared is 2, so it's this number. So whatever the exponent is, if something is raised to an exponent, if you take that root, then you're just left with whatever that number was, okay? Well, just in that way, if you have something, if something is say the 5th root right here, the 5th root, okay, of 4x, if you want to just make it 4x minus 8, okay, and not have that, the 5th root of 4x minus 8, all you have to do is just raise it to the 5th power, okay? Just the same as, okay, the square root of 4 is 2, okay? Well, if I just want this 4, okay, if that's what I want, all I have to do is just square this, okay? Because the square root of 4 squared is 4, right? 2 squared is 4. See how we did both the same thing to both sides? We squared that, and it also equaled 2 squared, okay? So, but they both equal 4. Okay, because we did the both, we know the square root of 4 is 2, and we know if we square both sides, we know they're still equal. Okay? So all you do is just raise this to the 5th power, all right? Raise both sides to the 5th power. Okay? So on this 22 here, we take this 5th root of 4x minus 8. If we raise it to the 5th power, what we've done is just eliminated that radicand right there. Okay, we don't have that anymore. So if we raise both sides to the 5th power, what we wind up with is 4x minus 8. If I could draw, we would be even better off. 4x minus 8 equals 2 to the 5th power. Okay? Now, we need to just add 8 to both sides. So we have 4x equals 2. I'll tell you what. Forget about all this explanation. Let's give us some room to work. So, okay, we raised both sides to the 5th power, and that got rid of our radicand sign, okay? So now we have 4x minus 8 equals 2 to the 5th. Okay? Well, I think you in your work, I think you've shown me enough that you probably know that this follows into 4x 2 to the 5th plus 8. We added 8 to both sides. Okay? I teach middle school, so I don't know how much I'm probably underestimating what you can do here, but anyway. So now we can do a couple of things. We could go ahead and divide by 4, divide both sides by 4. But let's go ahead and evaluate 2 to the 5th. Take it 2 to the 5th is 32, okay? So 2 to the 5th is 32, plus 8 is 40, still equals 4x. Now we can divide both sides by 4. This divides to 1, so x, divide that by 4. That's going to be 10. X equals 10, okay? And I think if we plug 10 back in, we're going to have 40 minus 8, which is 32, okay? So if we plug in 10 for x, okay, right there, that's going to be 40. You take away 8, that's 32. You take the 5th root of 32, I bet you that it is 2. Matter of fact, I know it is because 2 to the 5th is 32. So that is right. X equals 10. Okay? All right. Let's see. The dirty secret of math teachers is they usually they don't work problems live. They make sure they know how to do them before they do this. I'm kind of just doing this live, so we'll see how this goes. So anyway, I'm going to rewrite this one because this one has a lot of steps. 60 minus, well, I'm not going to rewrite it up there. So we've got 60 minus 1/20th x plus 75 to the 3/2 equals 10. Okay? Well, let's just start off doing what we can do. Okay? So let's subtract 60 from both sides. Our whole purpose is to isolate this x right here. So we're going to subtract 60 from both sides, which is going to leave us negative 1/20th x plus 75 to the 3/2 equals, if we subtract 60 from 10, we have negative 50. Okay, that's the 3/2. All right, so now let's go ahead and we are multiplying by a negative 1/20th. Okay, so we're going to divide by negative 1/20th, which just means that we multiply by the inverse, which just means we multiply by 20, okay, negative 20. So we know if we were to multiply these straight across, we would wind up with 1. A negative times a negative is a positive. So we've eliminated this. But we still have to multiply by negative 20, so the other side. So if we multiply this side by negative 20, okay, so negative times negative is a positive. We know that. 20 times 50 is 1,000. Not forget, this is to the 3/2. So that's 1,000. All right. Now, to the 3/2, okay? What this means is, anytime you see the fraction like this, it's raised to the 3rd power, and then you take the square root of it, okay? That's how you, that's what this means, okay? So to undo that, you're going to need to take it to the, basically the 3/2 root, but it's raised to the 3/2. But okay, I don't really know what happened just there with my little thing here. I meant to pause it, but I think we're recording now again. So the way I would rewrite this is I would go x plus 75. I would take the square root of that to the 3rd power, okay? So really equals 1,000, okay? That way I can go ahead and just take the cube root of both sides because this is raised to the 3rd power. So if I take the cube root of that, then I can eliminate this to the 3rd power. So I take the cube root of both sides, which leaves me with the square root of x plus 75 equals the cube root of 1,000, which I'm going to write over some of your work here. I think you can still see it. Cube root of 1,000, I believe, is 10. It is. So the square root of x plus 75 equals 10. Okay. Now this is the square root. How do we undo square roots? We square. We square it. Okay. So we square that. Then that takes away the square root. Anything, the square root of 16 is 4. If you square 4, you get 16. So that's what allows us to do that, right? That type of dynamic. So that's going to just leave us with x plus 75. We have to square both sides. Okay, so we squared that side. Get rid of this radicand right here, the radical symbol. So we square the other side. That's 100. Okay, we're going to subtract 75 from both sides. So x equals 25. We can always check our work when we're solving equations. So we plug in 25 here. That's going to be 100 to the 3/2, which will be 100 I'm going to pause while I check, make sure that's right. Okay, I'm back. I checked the math on it. Yes, plugged in 25 for x, and indeed, if you do that and do this, all these operations, you will get 10. Okay, let's do 24. This one doesn't look too bad. Okay, I am gonna rewrite it though. Let's see what's going on here. Okay, so we've got x on both sides, so we need to get our x's together. But in order to do that, we need to get rid of this radicand right here. So let's go ahead and square both sides. So I'm going to square this. I'm going to square this. Okay? Well, squaring this simply gets rid of the radicand. So we've got 19 minus x, right? the square root of something when you square it is just that something. Okay? Now, squaring this, I'm going to go ahead and write it where I can actually multiply it out so we can combine like terms. Okay? So we're going to do first outside, inside, last, okay, equals 19 minus x. That looks like x squared plus 2x plus 1 equals 19 minus x. We're going to add x to both sides, right? Or no, yeah, we're going to add x to both sides because we want all our x's on the same side. Okay? So we add x to both sides. It's going to cancel that one out, so we're going to end up with 19. We add another x to our two x's here, two x's right here. We're going to end up with three x's, so we have x squared equals 3x plus 1. We're going to subtract this 1 from both sides. Move over here. So now we have x squared plus 3x, excuse me. We subtract 1 from both sides. That's going to give us 18. Okay. It's looking like, okay. Again, had to take a few minutes to remember how to do something. So, all right, so now we've got it in this form, but this might look familiar as a quadratic, right? So let's go ahead and subtract 18 from both sides. So now we just have to figure out what will make this equal 0. So we know when we have a quadratic, right, we have to factor it out. So what we have to do is figure out what we put when we FOIL it. The answer is 3. I can see the answer is 3. I'm trying to think of the proper way to do this. Let's just keep on going and see what we get here. Plus 3. Okay. So yes, we can see that here. Okay. So in order for us to get 0, we need to get one of these. As long as we can get one of these parentheses to equal 0, then we're good. So if x is 3, 3 minus 3 is 0. 0 times this equals 0. but x should also be able to be negative 6. Because negative 6 plus 6 equals 0, which would be multiplied times this. So our roots could be 3 and negative 6. So I'm going to pause and make sure that that's correct. Okay. It's been a while on some of this, I'll be honest with you. 3 definitely works. That's easy to see. You could plug in 3 for x here. If you subtracted 3 from 19, that would be 16. Square root of 16 is 4. If you plugged in 3 for the x here, 3 plus 1 is 4. So negative 6 does not work out. It does give you 25. You take the square root of 25, that would be 5. But negative 6 over here would give you negative 5. So that one doesn't work out. So it has this has 2 roots, this quadratic, but the negative 6 one doesn't work. So 3 is that one. Alright, I'm going to think about that one some more. But anyway, let's move on to 25 here. Okay. I see some things written in here. They look like they're supposed to be there, so I'm gonna write this what I think it should be. Okay, hold on. I'm sorry. I think that's some work. Maybe that's the work you did. So it looks like this is 4 square root of x minus 2 equals square root of 5 minus x. Okay? Yeah. And this is... Okay. Alright, so first of all, yeah, the only thing we can do is square both sides to start out with. So, just like you said, we have to square both sides. That's going to give us 5 minus x. Now, when we square, I'm just going to go ahead and write it in FOIL form. We're going to know we're going to be foiling. So 4 square roots of x times 4 square roots of x is in our first. It's going to give us 16x. Okay, our outside is going to give negative 2x, or excuse me, negative 8x. Our inside is going to give negative 8x. So negative 16 square roots of x. Okay, and then our last is going to give us plus 4 5 minus x. Let's get all our x's on one side, so we're going to add an x to both sides. So x minus 16 square roots of x. We'll say plus 4 equals 5. We added an x, but I'm going to go ahead and just subtract 4 from both sides while I'm at it. So minus 4, and then we're going to minus 4 over here. It's going to give us 1. Okay, you look like Yeah. You look like you can follow that in the work you've done here. So that's 17. My pen is not calibrated exactly. Hold on, let me. Okay, hopefully my pen will be working better now. Well, this one, I can tell it's 1 because I know 17 minus 16 equals 1. Because I know if I plug in 1 for x here and the square root of 1 is 1. I can just kind of tell that by looking. I don't know. I'm sure that there's some more steps here. Let's see if we can come up with some. Okay, so I did take a peek at your work, I believe, and you were on the right track as far as squaring both sides, but you cannot square this 2 and this 4 square root of x individually. You have to square the whole thing. I think that's where you went wrong. Okay, these are pretty tough problems. So, well, I mean they're long, they're not tough, but so if we want to continue on with this, we can. I could just kind of tell at this stage that it's going to end up being 1, but if we wanted to really get down and solve it, it's going to end up being a quadratic, I believe, and we're going to have to find some roots. So what I'm going to do is square both sides. Okay? So 1 squared is 1, obviously. Go down here. Okay? So, but we'll go ahead and we'll FOIL 17x minus 16 square root of x. We know it all equals 1. So let's FOIL it out. 17 times 17. Okay, we got 289x squared. We'll have minus $272. Okay, so 272x square root of x. You would actually, and then the outside, the inside is going to be the same, the 272. So let's just go ahead and rewrite it. 286 x squared minus 272 times 2. 544x root of x. And then plus 256 x equals 1. Okay, I'm back, and this is what I know. This is a very hard algebra problem. There may be some sort of algebraic maneuver that I have forgotten, but as far as I can tell, getting it down to this right here and knowing that it to this and knowing that it equals 1 means 17 minus 16 equals 1, so both x's have to be 1, and 1 is the answer. As far as finding the roots, that's a tough one. I did a lot of work on it. I'm gonna have to actually do a little research to figure out how to technically solve for this problem to find to actually find x and solve for it. You can plainly see that it is 1, but let's get back to you on that one. So this is getting a little too long, but I'm going to look into it just out of curiosity, but I don't have time tonight. So good luck on the test. Hope this helps you.